Okay, so we're going to talk about the equation of a parabola. And we essentially have our two different types. Oh, and actually this is written wrong. That should say opens up and down. Just to make sure you have that right. So, in our first example here, this is an example when we have the x subtract the y value. So x squared subtract the y value with, depending what our denominators are, we try to set it equal to 1 so that our a's and b's are a little easier to work with. When set equal to 1, these rules all hold pretty true for us. And in this case, our rough sketch of this is a shape that looks like that. Okay. In our red one, where it's y squared divided by some value minus x squared divided by some value, it's same idea. The only difference is it's opening up and down, and they're not parabolas. They're a little bit differently shaped. In this case, our a values are x-intercepts. There are no y-intercepts because it's sideways. So these refer to whatever the a value is, and the oblique asymptotes run off of our a and b value, which are what we're being divided by here. And this transverse axis, we'll use it to help us graph our asymptotes, or essentially it'll help us with this idea here. We'll talk about how that does that. So in our very first case, we have 9x squared minus 16y squared equals 14, or not 14, 144. We'll relate this. So we're used to seeing our parent function written like this: x squared over a squared minus y squared over b squared, and is equal to 1. So that's the very first thing we want to do. Let's set this up so it's equal to 1. In other words, like you've done before, divide everything by 144. So we have 9x squared over 144 minus 16y squared over 144 is equal to a value of 1. So now what we have to do is relate this value to our a. Now, it looks like a is 12, but here it's technically a 1. So one way to look at this as an a value is our a value in this specific case. Think of it like a over 1. And 1 is technically the value in front of both of these. Okay. In our case here, we don't have a 1. Okay, we have a value of 9. So we have to substitute this 9 in for the denominator of our a value. Okay, so we know the a value is the root of the bottom number. Okay, so we'll take the root of this bottom number, and it's probably going to be the root of the entire thing in this case, right? So we're going to take the root of both the bottom and the top. We'll set it up like this. So in this case, our a, like we've done before, it gets put to the top value, 144, and the 1, or in this case, which is the 9, becomes the denominator of our a value. And the a value is the root of all of this. Okay, so our a will become 12 over 3, which is a very nice value of 4. Much nicer. In fact, we can rewrite this equation if we like in this manner, so it's a little simpler for us to look at. In our other example, let's find out what our b is. B is the exact same idea. Technically, the b value is 1 here. So in this case, we have, I'll extend it over here, we have b over 1, and it's all rooted, whatever the values are. Our 1 in this case is 16, so that's our denominator. And our b value is 144. Same idea. We root the whole thing to get what b is equal to, and b is equal to 12 over 4, which is a value of 3. Great. Now this is important information for us. It's going to help us out a lot more, because when we go through this now, let's go back up, we can really relate this to this information. For instance, our x-intercepts are a positive and negative value of a. Okay, so what that means is our x-intercepts, say x-intercepts, are a positive and negative value of a, so we have 4 and negative 4. Okay, so we got the first set checked off. The second thing we want to talk about is what are the asymptotes of these parabolas, or hyperbolas. Give me a sec. So next, we'll relate this information to the asymptotes. In this specific example, when we have the x value subtracted by the y value, our asymptotes are the b over a, okay, and which kind of switches in our other example. It's b over a, and it's technically positive and negative b over a x. This is our asymptote. Y is equal to, so it's a linear function. Since our b is 3, it's relatively straightforward to plug it in this way. We get 3 over 4 as our asymptotes. So we have y is equal to positive 3 over 4x, and y is equal to negative 3 over 4x. And our transverse axis being 2a, so we'll call it transverse axis, we said is 2a. So 2 times our value of 4, gives us a value of 8, and our conjugate axis is 2b. I should have wrote 2a here, so we see that note. B being, was it 3? Yeah. B being 3, so it becomes a value of 6. So we'll use this information essentially when graphing. We'll pull up a graph here. I think a scale of 1 will work fine. So, okay, so from what we got, we talked about how we have our x-intercepts. So those are the first things we'll go through. Our x-intercepts are positive 4 and negative 4. So we'll put those out. So we have positive 4 and negative 4. That works out good. Now, here's the second thing. We have asymptotes here. Okay, and we can draw these asymptotes, and they're probably not the most difficult things in the world to do, but these transverse and conjugate axes will, like you showed us, help us out quite a bit. The transverse, and this being our a value in this case, transverse is a difference of 8, and the difference of 8 is essentially talking about the difference between these two. So we set up, and this difference will always be easy to see because it's our intercepts. It's the other one that'll be a little tougher to imagine, this one being a difference of 6. Well, from the origin to be a difference of 6, our b values are 3, right? So because our b values are 3, we essentially go to positive and negative 3, and we create a rectangle like you said. We'll go right around here. From here, this gives us our asymptotes, right? If we draw straight through the vertices, we'll do this one going this way. Hopefully that's about right. And this guy here, there's one of them. And the other one, what we'll do is we'll test them with what we found our asymptotes to be. These should be our asymptotes. So simple to draw if we set up the rectangle. And according to this, we'll draw our hyperbola. If this is our x-intercept, it essentially follows this idea. We just kind of follow the asymptotes. And just to test these out, we can check out what the slope of them are, right? In the first case, our slope here is we went up 1, 2, 3, and we went over 1, 2, 3, 4. So that's a rise of 3 and a run of 4 in a positive slope direction, which is essentially one of the asymptotes. And in our second one, from our origin, we went up 3 and in a negative direction 4, so the idea being y equals negative 3 over 4x. So perfectly drawn, whether you want to follow the actual linear functions and graph them or set up this rectangle, both ways will work in this case. Just as proof, what we'll do is we've graphed the function. Here's the function, okay? And we can graph it several different ways if we want to see. And we just quickly put our asymptotes 3 over 4 and negative 3 over 4. And as we zoom out, you see that it essentially follows that line. The other way we wrote this function was 9x squared divided by 144, right? Subtract 16x squared.
16y squared.
Oh, thank you.
Yeah.
Y squared divided by, it's not division, 144 is equal to 1. And, oh, does it happen to be red again? Is that the color? Give me a different color here. Oh, I don't remember how I did the colors. Well, either way, you see when I take that red off or put the new red on, there is no difference. So we could write it either way. And actually, I think another way we could have written this is if we had done our x squared. And what this is going to do is just going to relate it to our a value. Do you remember our a value was in the end?
4.
4, I believe. Let's jump back and just double check. We'll zoom in. Remember, just so it was another way of writing, this is our a, right? So let's write it the way the parent function would be written. With a value of 1 here, we'll write a is 4 and see if we get the same idea. This being 4, it does need to be squared. So we write as 16 minus y squared divided by our value is 3, so 3 squared is 9 is equal to 1, and our blue goes right over our old one. So essentially, let's get rid of these ones in between so that we can see. There you go. We can see that we've written it 3 different ways, all of them being the exact same, except that we've written them differently, and these being our asymptotes in this case. Okay, that's good.